triangles PQR and LMN are graphed in the XY plane. Triangle PQR has vertices PQR at this, and this, respectively, and triangle LMN has vertices this, at this, respectively, where K is a positive constant. If the measure of angle Q is t degrees, what is the measure of angle N? Now, this is a type of question which most students will give up on easily, but don't feel intimidated by all of this information. Just draw the diagram for this, and since you have all the points, go to DESMOS, plot these points. So you can easily plot the points P, Q, and R, and you can get the triangle. So we'll go to DESMOS. So I have already plotted the points P, Q, and R. So point P, Q, and R. So you get this triangle. This is PQR. This is PQR. And for triangle LM and N, triangle LMN, point L is given. L is 4, 5, and point M is 4, 7 plus K, and point N is 6 plus K, 5, where K is a positive constant. So this K is actually a parameter. Okay. Now, in these type of questions in which you have a parameter, just assign a value to this parameter to solve this particular problem. Okay. And just keep in mind the conditions which are given for K. So K is a positive constant. So just take any positive constant. For example, take K is equal to 2. You can take any value of K. You can take 1, 2, 3, any positive constant, and put that value here. And with that value, you can solve the question and you'll get the correct answer. Okay, so if I'm taking K is equal to 2 for this question, so my point M will become 4, 7 plus 2, which is 9, and point N will become 6 plus 2, which is 8, so 8, 5. So I have also plotted these 2 points M and N on DESMOS. So you can see here, point M, let's call this point M, okay, and this one is point N. Again, you can take any value of K. Here I've just taken 2 as a random positive constant. Just make sure that you're taking a positive constant. So you get this angle LMN. Point L is same as point P. Okay. So this is triangle LMN. So now you'll understand that depending on the value of K, the size of the triangle LMN will change. Okay. But triangle LMN will be always similar to triangle PQR. If you don't understand this part, take another value of K, take 3, take K is equal to 4, and you'll see that triangle LMN will just increase in size, but it will be always similar to triangle PQR. Okay. Now, what do we have to find out? So it says that the measure of angle Q is t degrees. Then what is the measure of angle N? So measure of angle Q, this is angle Q, this is t degrees. So what is the measure of angle N? This one. Okay. So first of all, since these two triangles are similar, so all the corresponding angles will be congruent. So angle N will be congruent to angle R, this one. Okay. And you can see that since we have drawn these two triangles in the XY plane, in the coordinate plane, so this line is perpendicular. So your MP is perpendicular, sorry, QP is perpendicular to PR. Okay. So this angle is 90 degrees. So if this angle is 90 and angle Q is t degrees, so angle R will be 90 minus t degrees, and angle N will be also 90 minus t degrees because angle N is congruent to angle R. So the answer will be 90 minus t, which is answer choice C. Okay, in the figure, line segment LQ intersects MP at point R, and LM is parallel to PQ. So LM is parallel to PQ. The lengths of MR, LR, and RP are 6, 7, and 11 respectively. So MR is 6, LR is 7, and RP is 11. What is the length of line segment LQ? So we have to find out the length of LQ. Now, whenever you see two triangles on SAT, if you see two triangles, just realize that this question could be of similar triangles, or it could be of congruent triangles. Okay. The chances are that you'll get a question based on similar triangles, but you will have to identify whether these triangles are similar or they are congruent. Okay. They cannot be congruent because here you have 6 and 7 and here you have 11. If they are congruent, then they have to be exact copies of each other. That's why they're similar. And why are they similar? Because you have this angle congruent to this angle because they're vertical angles. And since this line is parallel to this line, so you have two pairs of alternate interior angles. First is this pair and second is this pair. Okay, so these two triangles are similar by angle criteria. And now you have to find out the length of LQ. So whenever you have to find out length of a side, set up the ratios. Okay, so first write the similarity statement. So triangle LMR is similar to triangle QPR. So this is the similarity statement. And now write the ratios. So LM over QP will be equal to MR over PR. That is equal to RL over RQ. Okay. Now, do we know the length of LM? No. Do we know the length of QP? No. So ignore this ratio. MR, do we know? Yes, MR is 6. PR is 11. RL is 7. RQ, we don't know. Okay. So from here, you get the value of RQ. So RQ will be 77 over 6. And if you select this 77 over 6, it will be wrong because you don't have to find out the length of RQ. Read the question carefully. Sometimes students make this mistake that they will select the answer choice that you get in the previous step. But you have to do one more step. You have to find out the length of LQ. So LQ, you can see from here, LQ is actually LR plus RQ. So LR is 7, RQ is 77 over 6. So this is going to give you 119 over 6. In convex pentagon ABCDE, segment AB is parallel to segment DE. The measure of angle B is 139 degrees and the measure of angle D is 174 degrees. What is the measure in degrees of angle C? So here we have a convex pentagon ABCDE. So here you can ignore the word convex. So basically your polygons are of two types, convex and concave. So a concave polygon is the one in which you have at least one reflex angle. Okay. And convex polygon is the one in which you don't have any reflex angle. Okay, so you just draw a normal pentagon. Just make sure that AB, line segment AB, is parallel to segment DE. So here I've drawn a pentagon where AB is parallel to DE. The measure of angle B is 139 and angle D is 174. You have to find out the measure of angle C. Now here you'll have to do a little bit of construction. So draw a line passing through angle C such that it is parallel to one of the segments. It is parallel to AB. And if it is parallel to AB, so automatically it will be also parallel to ED. So now these three line segments are parallel to each other. Okay. And this BC is actually a transversal, which is cutting the two parallel lines. So these two angles, this angle and this angle, both of them are on the same side of the transversal. So both of them will be supplementary. So this angle will be 180 minus 139. Okay, so that will be 41. And similarly, this blue line and ED, they are parallel to each other. So this angle and angle D will be also supplementary because they are on the same side of the transversal DC. So this angle will be 180 minus 174. So that is 6. So now your angle C will be 41 plus 6. That is 47 degrees. So the answer is 47. The perimeter of an equilateral triangle is 852 centimeters. The three vertices of the triangle lie on a circle. The radius of the circle is W times root 3 centimeters. What is the value of W? So we have a circle. So when they say that the three vertices of the triangle lie on a circle, that means the triangle is actually inscribed in the circle. And this is a special case. This is an equilateral triangle. So its perimeter is 852. And you know that an equilateral triangle, all sides are same. So let's say that each side is A centimeters. So 3A will be equal to 852. So value of A will be 852 divided by 3. So 3 times 2 is 6. So in 3 times 8 is 24. And then, so each side is 284 centimeters. Now we need to find out radius. So they've given an expression for radius, which is W root 3, W times root 3. So we need to find out the value of radius and we will put it equal to that value. And from this equation, we will find out the value of W. So in order to find out the radius, we'll need to do some construction here. So let's say this is the center of the circle. Now, whenever you have this type of situation, when an equilateral triangle is inscribed in a circle, and you have to find out the radius. So first of all, connect the center with one of the vertices of the triangle. So that is also the radius. And we have just found that one side of the triangle is 284. So, and I'm dropping a perpendicular from the center of the circle to this side BC, to the side BC. So when you drop a perpendicular to a chord, then it bisects the chord. Okay. So let's say this point is D. This is the center. So DC will be half of 284. Okay. So DC will be half of 284. So that's going to be 142. Okay. So this is 142. Okay. And okay. And now, since this, now you know, an equilateral triangle, all the angles are 60 degrees, right? Okay, so this angle is also 60 degrees. And this line segment OC, it actually bisects this angle. Okay, so this small angle, this one is going to be 30 degrees because half of 60 is 30. So this one will be 30. So that makes this angle 60 degrees. So this is a 30, 60, 90 triangle. Okay, so this side OD, which is the smallest side, OD will be equal to 142 over root 3. Okay, and OC will be equal to the smallest side times 2 because OC is the hypotenuse. So this is going to be the smallest side times 2, and that's the radius. Okay, so that's your radius. So your radius is also W times root 3. So you put it equal to 142 over root 3 times 2. And from here, you can get the value of W. Divide by root 3 both sides. So divide by root 3, divide by root 3. That is going to be 142 times 2 over 3. So this is going to be 2 times 4 is 8. 2 times 284 over 3. A right triangle has legs with lengths of 24 centimeters and 21 centimeters. So we have a right triangle. Let's call it ABC. So the legs are 24 and 21. It doesn't matter. You can give, like, it doesn't matter. You can take any length as 24 and the other one as 21. If the length of this triangle's hypotenuse in centimeters can be written in the form 3 times square root of D, where D is an integer. What is the value of D? So they have given the length of hypotenuse in terms of an expression. Okay, so you need to find out the hypotenuse first and set it equal to 3 root D. Now you can easily find out the hypotenuse by using Pythagorean theorem. So hypotenuse will be 21 square plus 24 square. 21 square is 441. 24 square is 576. So this is going to be 1 plus 6 is 7. 7 plus 4 is 11. 4 plus 5 is 9 plus 1, 10. So square root of 1017. And this is equal to 3 times square root of D. So we will find out its factors. So this is divisible by 3. So 3 times 3, 9, then you'll get 11. So 3 times 3, 27 is 339. Again, divisible by 3. So 1 and 1 and 3. And now, I think 113 is not divisible by any number. So this can be written as 3 times square root of 113. So the value of D will be 113. In triangle RST above, point W, which is not shown, lies on line segment RT. So your point W is somewhere here now. It doesn't matter where exactly is point W. We have to find out the value of cosine of angle RSW. RSW that will be this angle minus sine of WST, that will be this angle. Now I'll just draw this triangle here, and this angle is 90. This is the right angle. Now it doesn't matter where you're taking W. So this is S, this is R, this is T. Now you have to find out cosine of angle RSW. RSW is this angle, and minus sine of angle WST, which is this angle. Now you have to see that angle RSW and WST, they both add up to 90 degrees. See, angle RSW plus angle WST, they both equal to 90 degrees. That means both of them are complementary angles. Okay, and if you have two complementary angles, then your sine and cosine follow a property. So sine of theta is equal to cosine of 90 minus theta. This is the property. And also you can say that sine of x is equal to cosine of y if angle x plus angle y is equal to 90 degrees. So when you have two angles which add up to 90 degrees, if you add them and you're getting 90 degrees, so in that case, sine of that angle is equal to cosine of that angle. Okay, so basically here cosine of this angle, whatever this thing is, that is equal to this thing because they add. So cosine of angle RSW is equal to sine of angle WST. So their subtraction will give you a 0. So 0 will be the final answer. In triangle XYZ, angle Y is a right angle. Okay. So this is angle Y, X and Z. Point P lies on XZ and Q lies on YZ such that PQ is parallel to XY. So you have to draw this line. So this is parallel, PQ is parallel to XY. If the measure of angle XZY is 63, so this is 63. What is the measure of angle XPQ? You have to find out the measure of this angle. Now when these two lines are parallel, so this angle will be 90 degrees because these two are corresponding angles. Now in this triangle, this is 90, this is 63, so you can find out the third angle by doing 180 minus 63 minus 90. But 180 minus 90 will be 90, so 90 minus 63. Now 90 minus 60 is 30, and 30 minus 3 will give you 27. So this angle is 27. So this angle will be 180 minus 27. That will give you 153. Okay, and also you can use the exterior angle property. See, for this small triangle, this angle is actually the exterior angle. And any exterior angle is equal to the sum of two interior opposite angles. So this angle will be actually equal to the sum of this angle and this angle. So all you have to do is just do 90 plus 63, and that will give you 153. So 153 is correct.